This is Math 2, Unit 13, Section 2, which is volume. We'll start with 2A, which is volume of prisms and cylinders. A prism has two parallel bases, and so does a cylinder. So the base are the parts that are parallel to each other. So this shaded region, you can shade this in, would be parallel to the top shaded region here. It's not always going to be sitting on the bottom. So the base is not always the very bottom shape. It's just the two that are parallel to each other. If you take a look at this triangular prism down here, the base is the triangle here because it is parallel or will never touch this other triangle over here. The rectangles on the sides, they touch each other because they meet at an edge or this corner. But the two triangles will never touch each other, so we call that the base. And that's also where the prism gets its name from. So this one is a triangular prism. Because the two parallel bases are triangles. If the parallel bases were some other shape, then we name it by that shape, like a square or a rectangle. There is a square prism or a rectangular prism. You can also have pentagons as the base, etc. But when it's a circle, we call it a cylinder, but it has the same properties, and we'll talk about that on the next slide. So any prism or cylinder, you're going to take the area of that base, and we call that capital B. So capital B is the area or the shaded region of that base. And then we're going to multiply it by the height, which is the height of the prism, which is very important to know. It's not just any height, it's the height of the prism. Like down here, we're not going to multiply it by the height of the triangle, we're going to multiply it by the height of the prism, which is the distance between the two bases. Okay, so any distance between those two bases. So this base over here is a rectangle. So how do I find the area of a rectangle? Well, I multiply the length times the width, and that will give me this area of the rectangle. And then when I take the area of the rectangle, which is capital B, I multiply it by the height of the prism to find the volume. So what we're going to be doing in these examples is shading the base and finding the area of that base. So capital B means the area of the base, and in this case, it's length times width, which gives me 9 times 17. And 9 times 17 is 153. And then when I'm talking about the volume, I'm going to take the area of the base, which is capital B, and multiply by the height of the prism, or the distance between those bases. So the capital B I got from my first part, which is 153. And then the H is the height between the two bases that are parallel. So here's my other parallel base to the bottom one. Parallel means they'll never touch. All these other sides are touching. So that 24 is my height of my prism, and I multiply those together, which gives me 3,672. And my units are centimeters, and I'm talking about volume, so I multiplied 3 units together. Centimeters times centimeters times centimeters, 1, 2, 3, gives me centimeters cubed, or to the third power, because there are 3 of them. That's why we call it a 3-dimensional shape. It is measured, the volume is measured in centimeters cubed. Number 2. So you need to shade the base, and it might look different to you than it does to me, just based off of perception, but I'm going to shade this space right here, which means I'm shading the side that is 10 by 14. So my B for my base of length times width will be 10 times 14, which gives me 140. Then to find the volume, I take the area of the base times the height between those two bases, and that height is 4. So 140 times 4. That gives me 560 inches cubed. Okay, so we're going to go down to number 4 and 5 and do some triangular prisms. So I need to find the base. And in this case, this is a triangle, so I need to find the triangle here. Here's my triangle. And I'm going to highlight that and try to not cover up the numbers. But this highlighted portion is my base because it's the triangle, and it's parallel to the triangle behind it. Or, I don't know, maybe this is the bottom to you, above it. So when we're finding the area of the triangle, oops, remember we use capital B for area of the base. But basically, you need to know the formula for the area of a triangle. So if you forget, you have this page over here, and area of a triangle is 1/2 the base times the height. See how this is a little b? That little b stands for the base of the triangle. The capital B stands for area of the base, which is a shaded region. This base is two-dimensional. It can be shaded in. This base is a length, so it can just be measured as a distance. So if I'm doing 1/2 of the base of the triangle, which has to be perpendicular to the height of the triangle, I want to look at what my triangle would be outside of this prism. Excuse me. Okay, so if I rotate this and write my height is 7 here, your base has to be perpendicular to that height. So the 9 is not perpendicular to that height of 7. This side is also not perpendicular to that height of 7, so this side is. And I need to know what is the length of this side. Well, it would be the same as this length here, which is 12 feet. So we're doing 1/2 of 12 times 7, or 12 times 7 divided by 2. So that gives you 1/2 of 12 is 6. 6 times 7 is 42. And so when we find volume, I'm doing the area of the base times the height, or the distance between the two prisms. So that gives me area of the base is 42, and the distance between those two prisms, well, here's one triangle, here's my other triangle, so the distance between them is 5. So you do 42 times 5, and you get 210 feet cubed, because we're talking about volume. This next example is easier to see with the triangle, because the triangle is facing us, and the height that's right here is perpendicular to the base of 12. Now, it's kind of unclear whether this 5 means the diagonal here or the height straight down. So I'm going to show you that well, first of all, this entire thing is 12, so this is probably not 5. So we'll use this as the height as the 5. Okay, so when I find the area of the base is a triangle, so I'm doing 1/2. The base of the triangle times the height of the triangle. The base of the triangle is 12. The height of the triangle has to be perpendicular to the 12, which is 5. So half of 12 is 6. 6 times 5 is 30. So the area of this triangle is 30 millimeters squared. To find the volume, I need to do the area of the base times the height, which is the distance between that triangle and the other triangle. So the area of the base is 30. And the height is not measured up and down in this case. My height is my distance between these two. So this is actually as if the triangular prism is laying on its side. So the height is the distance between the triangle. So if you want it to look like a height, you have to set it on the triangle to do so. That's 16. All right, so 30 times 16 gives us 480 millimeters cubed. Okay, flip over to the back side. So you won't have to worry about any trapezoids yourself. Remember, we're going to start on number 9 and do some cylinders. Well, this works the same way, but in this case, my base is now a circle. So when I do the area of the base, this part right here is my capital B, and my base is just a circle. So the area of a circle is pi r squared. So you can use the formula pi r squared times the height to figure out the area or the volume of this cylinder. So we're just going to do pi times my radius squared times my height. My radius is 18 and the height, or the distance between the two circles, is 15. So 18 times 18 gives me 324. So I'm going to multiply that by 15. Remember, you have to do exponents first in your order of operations, so that's why we did 18 times 18 first. Multiply that by 15, and we get 4,860, and we still have pi, and our answer is in inches cubed. Okay, this cylinder is on its side, so that means the 21 is my height. So when I do pi times my radius squared times my height, the height will be 21 meters. The radius is not given to us. The diameter is given to us, so we have to divide that by 2 to find the radius is equal to 6. Well, 6 times 6 is 36, so you're going to do 36 times 21. And we get 756 pi meters cubed. Applications. The applications in this unit are very important because you will have a performance task to do at the end of the unit, which is similar to questions like this. So a cylinder with a 2 centimeter diameter is drilled through a rectangular prism shown on the left. So that means the rectangular prism was solid until they drilled out the core, which is a cylinder. It says find the volume of the prism. If you have a solid shape and you drill out the center, it's like subtracting the center away. So we need to find two volumes. the volume of the triangular prism. So I drew a little triangular prism next to my volume of triangular prism. We're going to subtract the volume of the cylinder. That's a cylinder right there, and it looks kind of like that image. So I'm just drawing little pictures, and that's going to give me my answer. So let's go ahead and do some work on this. The volume of the triangular prism, or you can write the word prism, is the area of the base times the height, where the area of this base is a triangle. So the area of a triangle is 1/2 times the base times the height. So you're going to find the base and the height of the triangle. Remember, your base and your height in the triangle have to be perpendicular. So 5 and 5 have that 90-degree angle there, so that's the base and the height of the triangle. This is your capital B. Remember, you still have to multiply by h, which is the height of the prism after that. So the distance between those triangles is 14. If you want, you solve the area of the triangle on its own. So you do 5 times 5 divided by 2, and that gives you the area of the triangle. And then multiply by your height. But we have half of 5 is 2.5. And then that times 5 gives you 12.5, and that times 14 gives you 175, or you can multiply all of these whole numbers and then divide by 2. But this, the volume of the prism, should be 175 centimeters cubed. Then I need to find the volume of the cylinder. The volume of the cylinder is pi r squared times h, where my radius, well, my diameter is 2, which the radius has to be half of that, so 1 squared. Well, pi times 1 squared is just pi times 1. So I get 1 pi, or just pi, for that core. So if I have to subtract that from the prism area, we take the 175, subtract pi, and we're going to leave it in terms of pi. You can't combine like terms because those aren't like terms. So 175 minus pi centimeters cubed is our answer. Number 12, a diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet, which is the height that it shows here, with a garden hose that has an 80 feet cubed per hour flow rate. How many hours will it take to fill the pool? So let's find the volume that he's going to fill first. So the volume is pi r squared times the height. My radius is half of the diameter, so this is the diameter, so 26 divided by 2 gives me 13 for the radius. The height here is 4, so 13 times 4 is 52, so 52 pi. Now this is in feet per hour, so I need to find the actual number that this equals. So 52 times pi, you can do on your calculator, 52 times pi is let's find mode. I'm going to change the mode here, so 52 times pi gives me about 163.4. So we're going to use that. This is approximately 163.4. And that's feet cubed. Well, I know that it fills at 80 feet per hour, so we need to figure out how many hours that'll take. So we take our total and divide by how many times per hour. That would be approximately 2.04 hours. Or you can say 2 hours is fine. It's going to be a little bit more than 2 hours to get those extra 3 cubic feet.